Good morning or good afternoon, everyone, depending on where you're at. This is Dan Hawkins, Director of Sales and Marketing for ThinkTech. Thank you so much for joining our webinar today on demystifying the IoT platform. We're going to be getting started here in just a moment, so please hang tight for us while a couple more folks are starting to show up. We'll get started here in 1 minute, so please hold the line and we'll go from there. Hello, everyone. For those of you all just joining us, we're going to be getting started here with our webinar momentarily, just letting a couple more folks get logged in and get ready to go. So we'll be beginning in about 30 seconds, so hang tight for us. All right, good morning, good afternoon, everyone. Again, my name is Dan Hawkins. I'm Director of Sales and Marketing here for ThinkTech. Thank you so much for taking time out of your day to join us for today's webinar. The topic of today's webinar is demystifying the IoT platform, where we are and where we're going. We'll walk through an agenda here in just a second, but before we get started, just a couple quick housekeeping items. All of your lines are currently muted. If you do have questions, feel free to go ahead and ask those in the chat. We are monitoring that throughout this session, and we will get to those questions here at the end of the webinar today. So our webinar today is scheduled from noon to 1 p.m. Eastern Time. And again, thank you so much for taking the time to join us. Our presenter today is Tim Quinn. Tim is an industry expert and CEO and co-founder of ThinkTech. Has many years of experience in creating, deploying, and with successful IoT project engagement. So very happy and excited to have him join us today. He'll be chiming in here momentarily as we get a little bit further into the presentation. Before we get started, I wanted to just provide a little bit of background about who we are as an organization. ThinkTech is an Atlanta, Georgia-based software company. We were founded in 2014, and at the end of the day, we're in the business of helping asset-intensive organizations. Those are organizations that own or operate or maintain expensive equipment, machinery, vehicles, personnel. We help those organizations drive digital transformation by leveraging the IoT to better collect, analyze, and be able to make faster and more informed decisions, which inherently impact both the top and bottom lines for our customers. So very excited to sort of demystify what a lot of people have told us is a bit of an emerging and a little bit more difficult to understand topic, which is the Internet of Things, or the IoT. And that's where we're really going to be spending a bulk of our time focused on today. Just to kind of walk through our agenda and what we're going to be covering today, we're going to do a quick round of introductions with Tim. We're going to talk through some common challenges and benefits of leveraging an IoT platform. We're going to kind of walk through common architecture for an IoT platform, the types of components that you would expect, kind of demystifying some of the verbiage from this space, and really putting that more in layman's terms to help y'all hopefully better understand a little bit more about why this is such a hot topic now, and why there's been a very large amount of investment made into IoT projects over the past couple of years. Then we're going to talk through some best practices in how to evaluate IoT solutions. We're going to talk about a couple of real-world use cases of how ThingTech customers are really leveraging this technology and on the cutting edge of starting to see very impressive returns on investment in using this type of technology. And then to wrap, we're going to take some questions from the audience and talk a little bit about how you can start planning for your own IoT project within your own organization. So that's what we're going to be covering today. And without further ado, I'd like to introduce Tim Quinn, who's our panelist today, who's going to be taking over from here. So Tim.
Excellent, Dan. Thank you so much. Let me get started and we'll get going. So I'd like to welcome everyone to today's webinar. Hopefully we can share some useful information and share some of our experiences, as well as take a look at some of the things that we're doing in the industry. And as Dan mentioned, what we want to discuss today is really, and we talk about IoT, but I'm really going to focus on, the industrial IoT. So it is slightly different than, say, a consumer-based IoT solution. The industrial IoT is really focused on not just a network of physical objects, systems, platforms, and applications, but it includes embedded technology and devices and sensors and things, quote unquote, things out in the world that need to communicate through the cloud, but also need to communicate potentially with each other in a decentralized model. And you're going to hear me talk about the edge today, which is a really big trend in the industrial IoT world. And things out on the edge are going to be very, very important in terms of the industrial IoT and how we move forward. But if you can digitize, the mission critical assets that you own and operate, whether it's a heavy piece of construction equipment, whether it's a sensor out in the world, whether it's a vehicle that has complex systems on board that vehicle, whether it's a power takeoff, whether it's a serial connection to a refrigeration unit, whatever it may be, we really want to drive digital transformation, and more importantly, we want to drive operational digital transformation. So what our customers see and what we're seeing with industrial IoT and applying a platform is our customers are growing their businesses and finding new business opportunities and new revenue opportunities through this concept of the IoT. We really hope and are seeing case studies where we're increasing operational efficiency. And what do I mean by that? Simply automating some processes, automating workflows, driving decisions so that they're faster based on real-time information. And if we can if we have pure visibility or 360-degree visibility into our operations, we can make better decisions, plan our assets, and how we deploy our assets more effectively, and then provide a layer of analytics to really give us the data we need to really generate actions. And the theme today will be actionable data. That is what we really want to drive home today. And then we also see a more connected customer with our IoT projects. Customers, your customers having more insight into your operations and visibility into, quote unquote, your things. And we'll talk about this concept of a thing out in the world. When we look at typical challenges, to the left are really just common types of assets, whether it's a construction vehicle, whether it's a sanitation truck, or a very expensive asset that has a lot of different systems and components attached to it, whether it's a heavy piece of equipment that's operated by a mobile technician or a equipment operator. It could be sensors out in the world. These could be infrastructure sensors. These could be energy sensors. Could be environmental monitoring sensors. But it's generating data. It's turned on. It can be turned off. It has a state and it has a status, and it's generating data that our customers need to understand of things out in the world. Or it could be a power, in this case, a power generator. But the point is, our customers own and operate a lot of different, what we call asset classes. We need to be able to connect to each one of those assets and those asset classes, bring the data back, generate actions, and generate analytics on top of it to improve our customers' business. But the typical challenges we see are things that we call the VAMP problem. The visibility where those things are located and how they're behaving. Accountability, are they being operated safely? Are they where they're supposed to be? Are things happening on that asset that we need to understand? How do you measure your performance metrics? Here's what this asset should do. Here's what it did do. Here's the productivity statistics, of my assets that I'm deploying. If we can get more efficiencies out of those assets, we can increase revenues, we can decrease costs while simultaneously improving customer service. And if we can improve the performance or get better data about the performance, we can actually detect things like potential asset failures, shut it down before it happens, or instruct a technician what to do once they get to the asset, if they're maintaining it, inspecting it, managing it, or delivering something to a customer. But the historical challenges, there's been a wall between the visibility, accountability, measurability, and performance problem and the assets out in the world. What we like to discuss are solutions. And so imagine if we could have equipment, many different types of devices or sensors out in the world, connected over multiple communication methods, cellular, a Wi-Fi connection, a TCP/IP connection, whatever that may be. We have things that we need to capture: location, utilization, diagnostics, performance data, and we need to bring that back into an application that's easy to use, that provides actions, and is connected to my back office. So there's many integration points in these types of solutions. This is an example of our solution, but generically speaking, it is a integration and data aggregation effort that the platform needs to support. We're going to talk a lot today about flexibility, configuration, and extensibility, again, so that we can model and manage any and every type of asset, regardless of the type of device, the type of sensor, the type of thing out in the world, pull it in one single container for analytics and action. That will drive operational digital transformation. And we talk a lot, again, about operational digital transformation because we see that as a big driver for our customers in terms of ROI and value. So when we combine, say, an enterprise asset management system with the industrial IoT and then the other components that can go around it, such as advanced analytics, maybe 3D mapping or virtual reality for your field technicians, we can deliver that to a mobile app. So anything that we want to, that's going on out in the world, we want to be able to have access to that on our mobile phones. We want to be able to take action on our mobile phones. We want to be able to generate a potential work order to deliver that to a technician that's the closest to the problem, navigate them to that location. And then once they get there, give them some insight on what they need to do to resolve the problem, and then help us understand what that problem was so we can fix it moving forward through advanced analytics, which I'll discuss. Now, when we talk about kind of the major components, just get us all on the same page. At least in our world, we kind of break it down into 6 areas. Things. Things are devices or sensors or a mobile, potentially even a mobile device. But it's something out in the world that's turned on, that's collecting data, that can communicate over a wireless connection and bring that data back. Now, when I say things, it could be a GPS device. It has telematics capabilities associated with it. It could be an RFID solution. It could be a sensor that's running on a battery, very low power, low latency sensor that's collecting data and sending that back. There's a concept of firmware. So this is very important in terms of evaluating potential IoT partners. The firmware is simply the software that resides on the thing itself or the device itself. And that allows us, in our case, to be able to control what that thing does, what it can capture, what it can't capture, what it supports, what it doesn't support. But it also controls everything around both the device out in the world, but also the device on the edge of the world, which I'll talk about in a second. Connectivity, how do we communicate the data back from the devices or those things? Cellular, Wi-Fi, socket connections. It could be a LoRa connection over a mesh network, communicating back to a wireless gateway connected back. But ultimately, what we want is make sure those things can operate in a decentralized environment, which means if we lose connection to the cloud, the things can still talk to each other. So it's thing-to-thing communication and thing-to-thing logic on the device itself. And I'm going to talk more about the edge, because this is a trend that I think we all need to be aware of moving forward, is how do these platforms manage the edge or the fog moving forward. There's many communication methods. I'm not going to go through all of these. There's tons of them. We're going to talk about the new ones that are being implemented or deployed, past the 4G LTE stage with low power wide area networks like LoRa or Sigfox, whether it's a Cat-M solution for sensors and be connected over a Wi-Fi connection, whether it's NB IoT. NB stands for narrowband IoT. That allows the same functionality to be communicated over a cellular network. And then the 5G network, which is coming online in many cities in the U.S., which will probably be a game changer for all of us. It moves about 100 times faster than any other of the other legacy cellular protocols. We're talking about middleware. This is the stuff that manages all the data moving from the thing to the cloud and to the edge. But we also have API services, because we have to be able to connect to other systems, whether it's a Salesforce CRM to connect your customers and field service, whether it's a SAP ERP system. We need to be able to connect these other systems to give your data context and to integrate it to make it useful for how you or your organization needs to understand that data. We talk about protocols, whether it's ISO protocols, MQTT, which is the sensor protocol for capturing data from a sensor, SAE protocols for vehicles and heavy equipment. Traditional TCP/IP protocols, of course, is connecting to a WebSocket. Open APIs and RESTful architecture is also important. And every now and then we do run into proprietary protocols that we have to be able to support on a piece of equipment. That's very important. We process that data through rules-based engine. It's very important. Now, we need to process that information we're collecting from these many, many things out in the world. And by the way, this could be millions and millions of records a minute. But how do we process it to create stuff that we call discovery data? What is it doing? Contextual data, combine it with other pieces of data to give it more sense. Predictive data, what is going to happen if this trend continues? What is going to happen, such as an asset failure? So how can I minimize or eliminate asset failures out in the world or on the construction side or out in the field before they happen? And then the big one is prescriptive data or prognostics. And prescriptive data is simply, here's what you should do based on the data we've collected. You should shut this machine down, or you should issue a work order to a technician to go inspect this to see what's going on. Ultimately, it's all about the user. What the user sees has to be very easy to use, has to be very actionable, and has to be very mobile in this day and age. So those are the components we tend to focus on in a very simple fashion. When we talk about connectivity, and so the challenges a lot of our customers have is how to get started. Well, if you can mix and match multiple devices and things and sensors out in the world, you should be able to mix and match communication methods. So that's what we call modular design. So within the thing itself, it could have a cellular modem. It could have just a Wi-Fi or TCP/IP connection connected to a Wi-Fi gateway. It could support Cat-M. It could support NB-IoT. Down the line, it should support 5G when that's available to all of us. The mixing and matching these communication methods is going to be very important in how and what you choose for your partner in the world of the industrial IoT. I don't mention, we don't go into detail here, but some of the things that are that are very important as it relates to low power wide area networks, say for sensors that need to have use very little power and often run on a battery or other form of power. LoRa and Sigfox are some emerging technologies that are being implemented across the U.S. and Europe and across the globe. They're going to be game changers in terms of being able to connect a lot of stuff out in the world in a very, very low power, low latency fashion. Okay, these are becoming more affordable and more prevalent than they were 5-10 years ago. Many of these were, well, all of these that we're looking on this screen weren't even available 5 years ago. So these are new trends that we need to be aware of and need to understand. The proper partner should be able to support all of them and bring them together, and to the end user, it should simply be seamless. I'm going to talk about semantics, or what I call thing semantics. And we talk a lot about device gateways. We talk about message brokers and how we broker the messages back and forth. We're going to talk about our rules engine and simply processing the data in a very fast and efficient method. And we said we need to be able to process millions and millions of records a minute and do something with it, which also speaks to scalability and big data and things like data lakes, which is just stores of data where you store data and you don't need it often, but every now and then when you do need it, go to the data lake and get it. Okay, so big data, data lakes are going to be important components of your solution. Registering the devices and managing the devices so we can shadow those devices is very important. And what I mean by shadowing a device, is what happens if that device gets disconnected from the internet or disconnected from the cloud? Well, that's where the edge would come in, where we still need to operate. That device still needs to be smart and needs to have logic on the device itself so it can still do everything that it could do, connected or not connected. So we're moving from a very centralized model historically to a mixed model of centralization in the cloud and decentralization at the edge. Okay, cybersecurity and IoT security has gotten a lot of focus recently, and how you secure your devices out in the world is a very, very important component of making decisions around how you deploy an IoT solution and what IoT solution to deploy. Okay. Now, very simply, to the left is the most simple view of industrial IoT or IoT: connectivity, devices or things, and analytics. This is probably the most simple rendering of the world of the industrial IoT. A pragmatic view would look more like this. We have a core IoT platform for your analytics, your device management, any other connected applications. You have an API layer that manages any processes, workflows, communication methods, any command and control stuff. And then you're connected to other applications, other systems, like enterprise applications, Salesforce. We have an app that plugs directly into the Salesforce CRM for the Service Cloud or the Sales Cloud to be able to understand where your things are in relation where they should be and give that data back to the CRM to create a more connected customer. You have third-party services. Well, what would these be? It could be real-time traffic. It could be indoor mapping of a building. It could be weather APIs to give me weather information and give me context for that data. What's the asset value chain? This is simply how do we optimize field service and where are things in relation where they should be and how are they performing, right? And obviously communications and controls of different assets out in the world, whether it's a dump truck, it's a water valve, whether it's a power generator, or another thing. And then how we connect it to your people, whether it's a field technician, whether it's a customer, or whether it's social media or chat, whatever that may be. When we look at our specific application, we talk about our view of the world, it's enterprise connectivity, GPS, telematics, diagnostics on machines. It's leveraging IoT sensors and things out in the world and communicating those back and forth via wireless communication to the edge, the fog, or the cloud. And of course, integrating to mobile, give me a work order, give me the ability to shut down a machine remotely, give me notifications, give me push notifications, alerts, and subscribe to data that I need to know about my machines. And then let's optimize the field. When I say optimize, how do I communicate to my mobile workforce out in the world to let them know what's going on and instruct them on how to maintain, manage, inspect, or deliver asset-related stuff. And ultimately, we want to put a very strong layer of advanced analytics on top of this solution to give insight and action. Okay? And we discussed earlier, this is our world and our view of it. This is the problem: visibility, accountability, measurability, and performance. As we move through the solution, problem, here's the solution, and what's the value? And we'd like to talk about automate, accelerate, enhance, and engage. Automate workflows, automate processes, accelerate access to data, accelerate the time to make decisions, help me solve real problems now versus discuss it 2 weeks from now. How do I enhance the data? Bring data back and give it context. Combine it with other pieces of data to make it more relevant. How do we engage both our customers as well as our mobile workforce to make them more productive, more efficient, but also to create a more connected customer through this type of data? So this is the world that we see, and what we tend to focus on, again, with our customers is operational digital transformation. And I talked earlier about data, and I also kind of mentioned here machine learning. These are all big buzzwords, but these are real things that should be really understood. And we kind of discussed earlier the 6 types of data. We deal a lot with contextual data. Does this affect what happens? So for instance, if I have massive windstorms on my construction site, does that impact the diagnostic related data that we capture in terms of what's failing? That could be an issue. But if I don't combine these two together, I don't get a lot of context. Prescriptive data or prognostic data is, what should we do? Give me some suggestions on what we should do to help resolve this issue based on the data we've captured, the trends, the patterns, and what we've learned from the data to help us make better decisions. We have the discovery data. Could this happen? What's going on right now based on the patterns and the things that we discussed? Any predictive data? What is likely to happen? If we're capturing diagnostic data and capture enough of it, can we put heuristics and algorithms on top of it and say, hey, this asset or this thing is going to fail if you don't do something about it? Okay, or predictive could also be based on my historical maintenance costs. What is my budget for 2019 for my preventive maintenance task or my corrective maintenance task? What's my capital planning replacement budget for the next 5, 10, 15 years? And of course, diagnostic data. Why did this happen? Because we had so many fault codes, or we had coolant temperatures were challenged with this particular asset. The edge, when we talk about the edge, again, these are the trends in 2018 that we're getting more focused on. I think the industry is getting more focused on, which is really the ability for things out in the world to operate in a disconnected or a decentralized fashion. So imagine if we all agree that things are out in the world that are generating data, they're turned on and off. There's information from those devices or sensors or machines that we need to understand. Well, imagine those talking to each other and not have to talk to a server through the cloud. So if we get disconnected, or if there's an asset out in the world or a vehicle out in the world, how can they connect to each other so that they're, number one, they talk to each other, but number two, they still operate, behave without any connection at all to the cloud. So that means logic has to be on the device, it has to be on the sensor through what's called firmware, and they have to be able to talk to each other in a very low latency, very fast way. Okay, so these are some So, and then what data do you capture at the edge, and what data do you capture in the cloud when it reaches the server? So the bulk of the data can be captured at the edge, and much of the data doesn't even have to be sent back to the cloud or through a cellular communication. That can all be done on the device itself, and we can bypass the need to go to the server, store the data, and come back with an answer. It streamlines that process and allows us to make much better decisions operationally. Okay, so then how do we combine that with machine learning? The success requirements for our projects have been around operational data for the industrial IoT. How do we combine operational data, and how do we combine operational knowledge into this framework and create what we call a blended framework? So that is what gives the data context, that what gives the application and the data that we generate and provide back to our users. That's what gives it meaning and gives it value. So the customers that we deal with, whether it's AB InBev, whether it's the state of Delaware, whether it's Fulton County Water Authority, whoever that may be, these are all industrial companies. They own millions, if not billions of dollars of assets. Their business is a function of those assets and how well they perform. So how do we combine the IoT or the industrial IoT and the operational data, the operational know-how, and the operational subject matter expertise to really drive strategic benefits, cost reductions, and improved revenues? We really look at these as the success requirements of projects. To give you kind of a visual of that, the things out in the world are here, of course, connected, whether it's a vehicle, whether it's a machine, a water meter, in this case, a wind turbine. How's that connected? And then how do we connect over the edge? Okay, so these can be connected through it could be a cellular connection, such as this. It could be a TCP/IP connection. It could be a Wi-Fi connection over a large area using, say, low power wide area network technology like LoRa or Sigfox, and then we bring it back to the cloud and back to the server for processing, logic, and warehousing of that data. And by the way, this data is extremely big and it's highly transactional. So you can collect 5, 6, 8 gigabytes of data per asset. You have 1,000 assets out there. You can kind of do the math, but this is kind of a conceptual rendering of that. Look at best practice again. The physical edge. These are physical things out in the world. Whether it's a sensor, whether it's a PLC, it could be a wired device, it could be a wireless device. It could be a wireless device that has very discrete input/output connected to other stuff on the asset, whether it's a power takeoff, whether it's an arm, whether it's a crane, whether it's a refrigeration unit on a trailer. These are very discrete things and other stuff connected to it. There's gateways, appliances, and points of presence where that data goes through. And of course, there's the application layer where that data comes back. This is really where the user interacts with the data collected from the physical edge, the kind of the middleware. This is what I would call middleware, the intelligent edge, and the business core. Okay. Now, let's review some use cases. And what we want to do and what we try to do at ThinkTech is make the industrial IoT practical and pragmatic. So let's talk about use cases. If we look here, we're connected to a bunch of stuff out in the world, or a bunch of things out in the world. These are vehicles, construction equipment, sensors. And we want to get the health of all this. Is it turned on? Is it turned off? Is it performing properly? I want to view it geographically. I also want to view it statistically or in a graph to visualize that more effectively. But I also want to capture diagnostics from that. That diagnostics could be engine data, diagnostic trouble codes, say from a vehicle or a backhoe. It could be diagnostic data, say from a sensor that's capturing data about the world around me, environmental data, for instance. So we want to capture that data, and then you also want to present that data and analyze that data through a rules-based engine for machine learning, things like I mentioned, predictive analytics, contextual analytics, diagnostic analytics, and prescriptive or prognostic analytics, and give it to me back in a fashion that allows me to do my job more effectively and more efficiently. Now, if we look at, say, a large organization that had many of the problems that we discussed earlier, visibility, accountability, measurability, and performance, well, their business challenge was making sure they had all their assets in one single place from a maintenance and a management perspective. They needed telematic data from their vehicles. They needed predictive maintenance information for their vehicles, their heavy equipment, their forklifts, and the refrigeration units. They're very focused on fuel efficiency and needed data from their fuel monitors to capture that information to make better decisions around fuel and emissions management. Okay, so when you look at where things are in relation to where they should be, we're capturing data, we're connected to customers, we're connected to coolers or refrigeration units, we're connected to tires and tire sensors. They're telling me what tire is, the tread depth is 2 and the pressure is 25. This is not good. And then give me a list of things I need to resolve or take action on. That's a real world pragmatic view. And we look at analytics, we look at before, and this is the solution before, which was done monthly on a grease board. Let's connect to the analytics platform and give real-time analytics and information to our users. So in this case, the red, of course, is bad. Let's do something about that now versus a month later when we discuss why it happened. In this case, we capture the data, analyze it, take action on it, solve the problem now versus discuss why it happened a month from now. Okay? If we look at public sector or Fulton County, in this case it's Fulton County, Georgia, and this is one of our earliest customers. This is actually the water authority. They had needs for all the fleet and heavy equipment telematics and location, but they also required API integration to things like an ESRI geographic information system, as well as water flow sensors. So to detect when water flow was failing or was an issue, they needed to understand that now to take action on it. And the action, again, could be dispatch a technician to our field service component, send them to that location, resolve the issue, and record the issue. And by the way, once they're there, tell them what they can do to resolve that issue in a more effective fashion. Okay, so in that case, we know we want to connect, diagnose the issue, so connecting and capturing all the types of data that we need to capture from the asset. We diagnose it, then we actually remediate it or solve the problem. Okay, it's a very simple use case, but it's very, very high value and had immediate operational value for this particular customer. When we leverage things like virtual reality, of course, we have the real-time components, giving us a view you'd think we should be able to see is clustered or is heat mapped. But we understand what's going on out in the world. We're capturing that data. We also have that on a mobile device. We can generate a work order or dispatch that to a technician. And by the way, also give it to them in the most optimized order to go solve the problem to reduce cost. But let's also give them maybe a route, but more importantly, let's give them more information to help them once they get to that location. So now let's leverage another technology that's becoming very, very popular in the industrial IoT, which is virtual reality, which is give us a different view of the data, which may be 3D mapping of the building. Now I have context around it. This versus this is much different, as well as this view and this view is much different. Once I get to the building, where is that inside the building? So now we're leveraging 3D virtual reality and inside the building, 3D mapping for navigation and optimization inside the building for field service technicians. Okay. So we're just blending other technology into the IoT platform to give it more context and give it better context. And really, in this use case, it's really just to do jobs faster and be more efficient in resolving potential issues or service deliveries. Okay, and machine learning obviously is a big buzzword. There's more tools available now than there ever been to analyze data. Processing is much more effective. Data storage is much cheaper. So now we can capture that data. We can baseline data. So if we capture gigs and terabytes of data a day, how can we analyze that data? Now, one thing that's important in the industrial IoT, and probably most of you that's on this call, is what we call time series data. Time series data is exactly what it sounds like. It's data that has a time value associated with a date and time. It normally also has a geospatial or XY coordinate or some a geospatial component to it as well. So we can not just analyze it from a time perspective, we can also analyze it from a geographic perspective and give it better context. In this case, we can look at potential anomalies. So we're baselining the data over a historical time frame. We're trying to develop patterns. We're trying to understand trends as it relates to your asset. And we're also combining geoanalytics into it. Well, what this allows us to do is explore these anomalies or any anomalies with machine learning algorithms and heuristics. So in this particular point in time, these are anomalies that we need to be aware of. We need to understand why that happened. Contextually, predictively, prescriptively. And these are the scatter charts of time series data. This red line indicates the baseline of the data. Okay, the outliers are the red. Those are issues that we need to be aware of. We can drill down to the hour, minute, second to give even better context. So this is a very important concept, and the tools available now are much greater than they have been historically for a lot of different reasons. But this is the type of analytics that should be available within the IoT platform. And kind of talk about other use cases. This is kind of an example of other things. This is a sanitation company that really wanted to integrate RFID technology. Well, RFID tags are things to us. It generates data. The tag generates data that's captured by a reader, and that reader can be connected over a wireless connection. So now we can blend RFID type data to geospatial data, even telematic data or power takeoff data. Was I in front of the house at this particular time, at this XY coordinate, and did the side loader actually get engaged at that particular point in time? Well, yes, it did, and we can prove it. Okay, so this is just now taking a much more complex asset that has multiple connections and sensors within that asset, but capturing that data, communicating that data over a wireless connection, and then giving context to a dispatcher, customer service rep, whatever that may be, within the office, okay? So, and by the way, also generate any alarms, any alerts, and give that back to another system. In this case, this is plugged into, this is the Salesforce app that's plugged in, our IoT platform is plugged into that app. And they have records of that in their CRM or customer management, customer relationships. I'm kind of wrapping up and leave a few minutes for questions and answers. This is the team, so things I like to mention are innovation. We really focus on innovation at ThinkTech and kind of making sure we're on the latest and greatest stuff and integrating to the proper devices and things to make a very easy to use solution that adds tremendous value, easy to get started, easy to maintain and manage, and a comprehensive solution where you bring really the entire package, the thing, the communication infrastructure, as well as the software, all in one comprehensive solution. Partnerships are big in terms of who we partner from a device perspective, from a communication perspective. Sustainability, we focus on sustainability in terms of environmental sustainability and really helping our customers do positive things. And we're very fortunate that our platform can be deployed not just to the private sector like, say, AB InBev, we can deploy it to cities and states to improve the communities around us, improve the how government is delivering services, how they're reducing costs, help them create a more environmentally friendly environment, reduce emissions, reduce carbon, all those good things. So it's very, I guess I'm on my soapbox, but it's great to be able to have extremely positive impact to our customers and the communities that they serve. 2018 beyond, we can continue to stay on top of the best practices for industrial IoT and connected devices and field service automation, and make sure we blend these technologies into one single application to drive digital operational transformation and solve the visibility, accountability, measurability, and performance problem that many of our customers face. I'm going to turn it back over to Dan, and we'll wrap up. And I think Dan said he may have some questions. And if I didn't cover something that is of interest, please let us know, and we can respond back. Thank you very much for your time. I hope this was helpful. Dan?
Tim, just a few questions that came in from the audience during our presentation here. The first one came into us. The question is, what are some common pitfalls to look out for when planning for an IoT project?
Oh, good question. Well, business requirements and kind of why are you investing in this type of solution is one that I think all of our customers need to really understand. What are the use cases you're really trying to solve? Are you trying to reduce costs? Are you trying to improve your efficiencies, say, for assets? Or do you have a maintenance issue that might be a problem? Those are just the requirements of why are you investing in this type of solution, and does it add value to your organization? What we've seen is usually, if that's worked out well, these types of solutions, our type of solution or platform, really adds a lot of value to the operations if the business requirements, use cases are defined. That's certainly one. And then the choice and selecting the proper partners also obviously very important. And of course I'm biased, but selecting a solution that can scale with your business. When I say scale, can the solution support all the assets that you own and operate? Can it support multiple things, quote unquote things? Is it extensible? Is it scalable? Can it process millions of records? And how long does it store the data? If you're gonna want valid machine learning, you better have at least 6 months, 12 months of really strong data to analyze in order to infer the proper analytics. So we see solutions out there that store the data for 30 days and throw it away. So making sure that you have a scalable and extensible partner that really solves your specific use cases is one that I would probably say is the most important.
Tim, another question that came in from the audience here. So we're in the current planning stages around a potential IoT project and trying to determine who the key stakeholders within our organization are. What type of roles do you typically see involved in the projects that you've been working on at ThinkTech? And who you would consider to be critical members of a team to evaluate and launch a solution like this?
A great question, and it's three. And if you can think about a triangle, and at the top of the triangle is the executive sponsor that really is invested from a leadership perspective that they're going to make the project work is a very important factor. If you look at the triangle below, to the left and to the right, you have your operational stakeholder, the user, the person that needs the data, that needs the analytics, that needs the actionable information in order for him or her and the people around him or her to make better decisions. And those are the users. And those are critical folks to have on board early on. Because when we mention the IoT, it's operational, the blending of operational data and operational know-how with the IoT. And IoT infers the other stakeholder, which is the IT department, the technical representative of your organization that would be driving this. Those three stakeholders, executive sponsorship, operational stakeholder, and the IT stakeholder, all have to be in step and aligned with what the project is and what the requirements are, and what are the success factors to say this is a successful project. There's been a lot of false starts in this world. It's early, and usually it fails with one or more of those not being in tune. And to be honest, we have a few case studies where we could share down the line where that exactly happened, and we had to re-engineer or reshuffle a few things to get realigned with those three stakeholders. So those are very, very important. Those three are, in my opinion, the most important to make sure you have aligned.
Excellent, Tim. And one last question. We actually have two. I'm going to kind of merge these into one question here. Both of them really around sort of the ROI of implementing an IoT solution. So the question really is, firstly, what areas of my business will be most impacted by an IoT application deployment? And what are the most common areas that you see the biggest gains for customers who deploy an IoT solution?
Okay, good question. So if we take the first question, what area is going to probably be impacted the most, at least in our world, in our experience, and our being the collective ThinkTech opinion, is operations, and will probably be impacted the most in terms of potential business process changes and positive impacts how operations, day-to-day operations, are being managed. And when I say operations, automating processes within the operation, moving from a paper system to a mobile app, for instance, is an operational change. The data that we're capturing now will feed into operations so that they can make better decisions now. And these are day-to-day, quote unquote, meat and potato tasks, like this thing's about to blow up, somebody needs to shut it down. So when you look at how this type of technology impacts operations is the biggest, probably the biggest area of positive impact. Probably the second one is because you're also getting efficiencies with your field service. You're getting better optimization on route planning, dispatching, asset maintenance and management. The second one is probably customers, just giving visibility into assets or things out in the world that the customers that you're servicing. If you're a private sector, it could be your customers want to know, did the asset leave my facility, or did it is it still there, and how many assets are turned on right now, or whatever that may be. If it's connecting a citizen or a customer out in the world, of giving them ETAs of when things are going to be done or things have been done is going to be a big. It's going to be an option to really significantly improve service delivery. And then the second question of that was, what was the second question, the part B of that question?
Yeah, part two of that question was, where does the tangible ROI come from? So where do your customers see the biggest gains?
Okay, that's a great question. So they will almost immediately see reductions in just the day-to-day cost, your daily operational costs, whether that's labor, whether it's how much you spend on replacing assets or maintaining assets, are certainly almost immediate. The other areas that we see in terms of real tangible ROI is the opportunity to improve efficiency of the asset. So those revolve around reduction in fuel cost, reduction in maintenance cost, reduction in massive correctional maintenance costs of things that blowing up and having an unexpected massive maintenance bill for very expensive equipment, and then the productivity efficiencies gained by really understanding what my plan productivity was for tomorrow and what we actually did. Having that data to be able to improve the what we call asset deployment and asset planning generally generates new incremental revenue opportunities to do more with less. So what I mean by that is if we have a real-time view operationally, we can make better decisions day of service or day of operations to make sure that we're getting more from each asset or each mobile worker, and they can actually do more for less. And the best example is can we deploy this technology, optimize maintenance or inspection schedules on a daily basis, and rather than do 5 inspections a day or 5 maintenance tasks a day, can we do 8? And that really generates new incremental revenue, and it also will allow potential service to add additional service options or even combine services and programs to create a more connected customer. So, and the customer service, customer satisfaction is kind of intangible, but that will come with it, if that makes sense.
Excellent. Well, Tim, thank you very much for your time. Audience, thank you so much for joining us today. Just to quickly recap, so we talked through at a very high level some of the benefits that organizations can potentially achieve by adopting this emerging IoT technology. We talked through some of the tangible benefits and ROI from adopting a platform such as ThinkTech. We walked through some common IoT terminology, how it's architected, common protocols that you're going to encounter as you're beginning to research a project like this. We discussed some practical applications of IoT technology and how it's being used today. We talked through some things to consider as you're beginning to think about the practical application of this technology within your own business. And then we shared with you a few real-world use cases about ThinkTech customers are beginning to use this technology and see tremendous returns on investment almost immediately from leveraging the IoT. We would strongly encourage you, if you're interested to learn more or are thinking about a project like this yourselves, feel free to reach out. We'd be happy to schedule a complimentary consultation with one of our IoT experts here at ThinkTech. And we certainly look forward to that discussion and working with all of you at some point in the future. So with that, we'll wrap up today. This session has been recorded, so we will distribute that out to the group after this, and as well, we'll make it available on our website for you moving forward. So thanks again for the time, and have a great rest of your day.